how many animals should I use? Okay? What would be the consequence if I use too many animals or too few animals? If I use too many animals, I mean, an animal is a life. Okay? We do not waste life indiscriminately. That's unethical. Okay? What if I use too few animals? If I use too few animals, I do not get the conclusion. I do not have the statistics to tell me whether it's true or not true, or I don't know, period. Okay? If it ended up that I cannot draw any conclusions and I don't know, then all your effort is wasted. And those few animals that I've used have wasted their lives. So it's very important to use statistics to calculate the correct sample size so that you do it right and do it once. And then in clinical research, many physicians would review charts, review the past experience of the clinical data, and from there to test the hypothesis whether this type of treatment is better than the other or the same. And in that kind of analysis, very often we need to control for many variables that may account for the outcome. So very often we would end up needing to use multivariate analysis. And in clinical trial, in order to design a clinical trial to test whether a drug is effective or not effective, you need to plan for the statistical analysis of the primary outcome. And also, again, this is even more important that when you're dealing with humans, okay, you may be dealing with human lives, okay, or injuries, potential injuries to patients, that your sample size calculation needs to be done properly. And then, after multiple clinical trials have been done, what is the collective experience? What is the conclusion based on multiple clinical trials? In order to do that, there's another statistical methodology called meta-analysis. It is the analysis of analysis. So when we do research, or when we design experiments, randomness is very important. But random does not mean haphazard or unplanned or incidental. Like, for example, allocating patients to the treatment group on even days, or allocating to the control group on odd days. It's a systematic method of allocation of the patients, and it's not a random allocation. Assigning patients with odd medical record numbers to the treatment group or even medical numbers to the control group is a systematic method of assignment of the patients to the groups. It is not a random assignment. Random refers to the idea that each element in a set has an equal probability of occurrence. It's like flipping a coin, provided that that is a fair coin with two sides, right? If you have a coin that with the same figurehead on both sides, that's not a fair coin. Or rolling a dice, okay? It has to be a fair dice, okay? If you're rolling a dice loaded with mercury, that's not a fair dice. Random number generator. Now, these days, with computing technology, with random number generators, it's a pretty fair way of randomness to guarantee that the randomness of assignment. Very often these days when we do research, we record our data using spreadsheets. And I mean, not that I am trying to advertise for Microsoft, but I'm sure that Microsoft Office Excel spreadsheet is one of the most popular spreadsheet used. But there is a limit with Excel that the maximum number of rows is about 65,000, and the maximum number of columns is 256 columns. But as a general tip of how to use these spreadsheets, okay, keep the variable names at the first row. Because within this Excel program, you can freeze the first row so that when you scroll the data, okay, you can have the first row in sight so that you can keep track of which variable is which, so that you won't get confused. And also to facilitate transfer of data and compatibility with other programs, you need to keep the names, the variable names short and without spaces. And the entry into each box should be a number or a string of characters. And they should be uniform in units. Okay, they either represent a quantity of a quantitative variable or a category of a categorical variable. And enter as little text as possible and use quotes. Now, for example, you can use number 1 to represent male, and number 2 to represent female. Okay? But in order for you not to forget and confuse later, number 1 is male, or is number 1 male or female? I forgot. So you need to write it down somewhere. What I usually do is to use the next sheet 2, to make what we call a data dictionary. Okay? You write down what the codes mean on a separate sheet, not on the same sheet, because if you write it on the same column, okay, if the data collected in the column is not uniform, it will have a tough time doing analysis later. But keep the free text comments away from the data fields. Okay? Because if you put comments or non-uniformity in the columns, would give you trouble when you try to sort the data. So here are examples of the good, the bad, and the ugly of the spreadsheets. Here is an example of a good spreadsheet. Here you can see that under the variable sex, you have M for male, F for female, and it's uniform, okay, for the rest of the entries. Under age, okay, you can specify that the unit is years, and then you have to make sure that all the numbers that you have entered are years and not months. Okay. If you put year on one box and months on the other box, when you do the calculation, you end up with wrong calculations. So again here, all the numbers are uniform, and the data and the text fields or categorical variables are uniformly coded. Okay. This is a bad spreadsheet. Why is it bad? Under sex, you have M for male, and then you type out the whole word male. Okay? Although, you fully know what it means, but the person that's going to do the analysis is going to hate your guts. Because he has to go back, or he or she has to go back and edit the entire spreadsheet to make the coding uniform. Here, under age, okay, 55 years, okay, and then 45 years and 3 months. My God, the person that's analyzing the data is going to hate your guts because he has to go back and calculate and transform this 45 years and 3 months into 45.25 So you're going to give the person doing the analysis a lot of griefs if you just do this on the spreadsheet. This is a bad spreadsheet. And this is an ugly spreadsheet. Look at that. It's too many colors. It's distracting. And also, different pieces, different formats in different places. And this is also a nightmare for analysis. The person would have to cut and paste and copy the data to a different spreadsheet and rebuild the spreadsheet before the analysis can be performed. So what are the types of data and the levels of measurements? There are nominal categorical data, for example, gender or race, or whether the patient is hypertensive or not. It's categorical, okay? Either you're hypertensive, or you're not hypertensive. Or ordinal type of data, meaning that these are categories that can be ranked. Okay, for example, we're talking about a smoker, okay? How heavy is the smoking? None. A non-smoker, okay? The next category is maybe smoke a little bit, light smoker, a moderate smoker, or heavy smoker, okay? These are discrete categories. But these categories can be ranked in terms of severity. For example, stage of a cancer, whether it's stage 1, or stage 2, or stage 3, or stage 4. Okay, these are discrete categories. But each category, the rank order of the categories has a meaning. It represents the degree of spread of the cancer. With discrete numerical data, the number, we're dealing with numbers. For example, number of cells. Okay, these are, it must be whole numbers. You don't have half a cell. You don't have 0.25 cell. Or patients, number of patients. Okay, you either have 1 patient or 0 patient. There's no 0.2 patient. Or data that belong to a continuous scale. For example,